All right, in this video, we're going to go ahead and look at compositions of functions. Okay, before I get too much into those, I just want to review evaluating a function. So here I have two functions, f of x, which equals 4x plus 8, and g of x, which equals x squared plus 5x minus 4. So when I see f of negative 5, what I do is I just come up to this function. Wherever I see an x, I replace with negative 5. So in this case, it's going to be 4 times negative 5 plus 8. Well, 4 times negative 5 is negative 20. And then I got to do the plus 8. Negative 20 plus 8 is negative 12. So the value of f of negative 5 is 12. Basically, that means when x is negative 5, y is 12. Now here I'm trying to evaluate g of 2. So I come up to g's function. Wherever I see an x, which there's multiple x's here, I replace it with a 2. My suggestion, anytime you're replacing a variable, put it in parentheses. So here I have a 2, so I want to do 2 in parentheses squared, plus 5 times 2 minus 4. And we can pretty much type that in the calculator. I'm going to do this by hand though. 2 squared is 4, 5 times 2 is 10, and then I got minus 4. So 4 plus 10 is 14, minus 4 is 10. So g of 2 has a value of 10. Now I want to go ahead and do f of 10. So again, I come back to f, the function f. Wherever I see an x, I replace it with 10. So that's going to be 4 times 10 plus 8. 4 times 10 is 40. Plus 8, I get 48. Now if we go to g of negative 12. Using g's function, wherever I see an x, I replace with negative 12. So again, let's put it in parentheses, negative 12 squared plus 5 times negative 12 minus 4. If you forget to put that in parentheses and you do it in your calculator, you will get the wrong answer. So when I do negative 12 squared, I get positive 144. 5 times negative 12 is negative 60, and I get minus 4. So 140 minus 60 is 84, minus 4 is 80. Okay, now these next ones are a little bit more difficult. Okay, I don't have a number value here. I have an expression, in this case x plus 4. So here when I go up to f of x, wherever I see an x, I replace it with x plus 4. So here I had 4x plus 8, so now it's going to be 4 parentheses x plus 8, and then plus 8. And now I just need to simplify this algebraically. Get rid of my parentheses by distributing the 4. That gives me 4x plus 32, and I still have that plus 8 at the end. Now I can combine my 32 and my 8, so my final expression is going to be 4x plus 40. Okay? Now over here I have a function where I want to do g of 2x. So again, I go up to g's function. Wherever I see an x, I replace it with 2x. So this is going to be parentheses 2x squared plus 5 times 2x, and then minus 4. So when I do 2x squared, I got to do 2x times 2x, which actually then gives me 4x squared, because I have to square both parts, the 2 and the x. Here I have 5 times 2x, which is 10x, and I get minus 4. So that would be my expression. Okay, now that's going to lead us into compositions of functions, okay? A composition of functions can be written two ways. You will often see it as this way, this, or this. And a lot of people refer to these as Fogg and Goff, because it's f circle g of x, okay? I prefer writing it this way, and the reason I do that is because this shows the g of x in parentheses, so it tells me to do inside the parentheses first. Now when I read this, this is read as f of g of x. Down here, this is g of f of x. Okay, when we evaluate these, and the reason I like this notation is we're going to evaluate, in this case, g of x first. Whatever we get, we'll then plug into f. And once we do a couple examples, hopefully that'll become a little more clear. Down here, we're going to evaluate f of x first, and then plug it into g. Okay, so let's just go ahead and do a couple compositions of functions. So I have two functions here. These are the exact same two functions I did before. Okay, so nothing's changing there. So on question 1, I want to do f of g of 2. And my recommendation is start by rewriting this in the other order. Okay, so this is going to be f of g of 2. I want to evaluate what's inside parentheses first. So I want to know, what is g of 2? Now I purposely picked this one because we did it already, okay? In this case, g of 2 had a value of 10. So I don't need to reevaluate that. So I know g of 2 has a value of 10. So now I go to f's function and I just plug in 10 because I know g of 2 equals 10. Replace it with 10. So now I go to f's function, replace x with 10. So I get 4 times 10 plus 8. So that's 40 plus 8, or 48. Okay, now let's try another one, number 2. I want to do f of g of negative 5. So first of all, I want to evaluate f of negative 5. I like doing that off to the side. So if I come to this function, it's 4 times negative 5 plus 8. That's going to be negative 20 plus 8, or negative 12. So now, if I rewrote this, I should have rewrote this first. I should have rewrote it as this, g of f of negative 5. That's why I did this f of negative 5 first. I know it has a value of negative 12. So this is then g of negative 12. Well, when I plug negative 12 into g's function, that's what I did already. Okay, when I plug negative 12 into g's function, I got 80. So I could tell from here, this I know is going to in fact be 80, and I'm done. All right, let's do this one here. I want to do f of g of negative 5. And this is written in the notation I prefer. So off to the side, I want to evaluate g of negative 5. Okay, well, I have g's function up here. I know we can't see it on this anymore. So I'm going to replace x with negative 5. So I have negative 5 squared plus 5 times negative 5 minus 4. So here I get 25 minus 25 minus 4. That gives me a value of minus 4. So I'm going to replace g of negative 5 with its value, negative 4. So I'm going to do f of negative 4. So I come up here to f's function. Wherever I see an x, I replace it with negative 4. So this is 4 times negative 4 plus 8. So negative 16 plus 8, which gives me a final value of negative 8. Okay, the last two are going to be a little more complicated. All right, number 4, when I'm doing this, I want to evaluate f of g of x. Basically, we're writing a rule for the composition, okay? So g of x does not have a number value. I'm not going to get a nice number value like I did in previous problems. Like here, I found out g of 2 was 10. No, g of x just has its expression. So g of x is this expression, x squared plus 5x minus 4. So I'm going to replace g of x with its expression. So I can say that's f of x squared plus 5x minus 4. And so now what I'm going to do is I'm going to go over to f's function. Wherever I see an x, I got to replace it with this entire expression. So f is 4x plus 8, so it's going to be 4 times all this stuff, and then plus 8. Okay, so now I just distribute my 4. I get 4x squared plus 20x minus 16, and I still have that plus 8 hanging on at the end. So this becomes 4x squared plus 20x minus 8, and I'm done. All right, the last one gets a little more complicated yet. Here I want to evaluate f of g of 2. Okay, we can't see what f of x and g of x are, so I'm going to rewrite them down here in case you don't have them handy to see. All right, so this I want to do f of g of 2x. So what I'm going to do is I'm going to evaluate g of 2x first. Okay, so this is going to be 2x. I'm going to go to g's function. Wherever I see an x, I replace it with 2x. So it's going to be 2x squared plus 5 times 2x, then minus 4. So like we did before, when I do 2x squared, I'm doing 2x times 2x, which gives me 4x squared. Here I get plus 10x, and then minus 4. Okay, so that's the value of g of 2x. So now I'm just going to replace g of 2x with that expression. 4x squared plus 10x minus 4. So now I go to f's function, wherever I see an x, replace it with that expression. So it's going to be 4, then 4x squared plus 10x minus 4, and then plus the 8 at the end. Okay, distributing my 4 here, 4 times 4 is 16, so we get 16x squared. 4 times 10 is 40, so we get 40x. And then here I get minus 16, and the plus 8 still hanging on there at the end. I can combine my like terms. My final answer is 16x squared plus 40x minus 8.